The sound is apocalyptic. Giant mechanical claws lift entire cars like toys, while colossal shredders devour vehicles in seconds, transforming them into mountains of metallic fragments. What was once a family sedan is now just 3 tons of pure steel, ready to be reborn as a new automobile. In a single automotive recycling megafactory, 50,000 cars are processed monthly, one vehicle every 17 minutes, 24 hours a day. Building-size machines operate in destructive and creative symphony, separating precious metals, plastics, and glass with surgical precision from a mountain of scrap that looks like total chaos. But here's the impressive reality. 95% of each car can be completely recycled. That engine that no longer works contains enough iron to manufacture 25 bicycles. The plastic bumper will become a part of a new vehicle. Even used fluids will be purified and reused. Nothing is wasted in this industrial cathedral of circular economy. How is it possible that an automobile graveyard transforms into the purest and most valuable raw material source in the steel industry? How do machines manage to automatically separate 200 different types of materials from a confusing mass of twisted metal? And how does this invisible industry process 80 million vehicles annually worldwide, transforming end of life into new beginning? The answer is hidden in the depths of megafactories that operate like living organisms, where destruction and creation dance in perfect harmony. Prepare to discover how billions of tons of dead metal are reborn as virgin steel in a process that redefines the concepts of end and restart. Automotive recycling was born from necessity during World War I. In 1917, when steel became scarce for weapons production, governments began collecting abandoned cars to extract metal. Local blacksmiths dismantled vehicles manually, separating iron from other materials with primitive hammers and chisels. The true revolution came in the 1930s, when Harry Schnitzer created the first organized automotive recycling yard in Portland, Oregon. His innovation was systematizing the process. First, drain fluids, then remove reusable parts, and finally compress the carcass for efficient transport. The modern automotive recycling industry was born. World War II dramatically accelerated innovation. The demand for steel was so intense that government campaigns encouraged citizens to donate old cars for the war effort. Improvised factories processed thousands of vehicles, developing techniques that would become industry standard decades later. The 1960s brought the first significant automation. Hydraulic presses replaced manual hammers, while magnetic cranes moved carcasses automatically. The Environmental Protection Agency, EPA, established regulations that transformed recycling from necessity into legal obligation. The 1973 oil crisis revolutionized the industry. Suddenly, recycling became economically attractive, not just environmentally necessary. Shredders, machines that shred entire cars, were developed, increasing processing efficiency by 1,000%. The 21st century brought artificial intelligence and advanced robotics to automotive recycling. Computer vision systems automatically identify materials, while high-precision magnetic separators recover metals with 99.9% purity. Today, the industry processes more steel than many mines produce. The transformation journey begins in reception yards, where trucks unload hundreds of vehicles daily. Automatic weighing systems register each car, while radioactivity scanners detect hazardous materials. Certified operators visually inspect each vehicle, identifying components requiring special removal. Fluid drainage is the first critical stage. Automated suction systems remove engine oil, transmission fluid, fuel, coolant, and brake fluid. Each fluid is collected separately in specialized tanks for subsequent purification and reuse. Not a single drop can contaminate the soil. Selective dismantling removes valuable components before shredding. Specialized robots extract batteries, catalysts, airbags, and electronic components. Parts in good condition are cleaned and cataloged for resale, while hazardous materials go to specialized treatment. Primary shredding happens in colossal machines called shredders. 500-kilogram hammers spin at 400 RPM, fragmenting entire cars into 10-centimeter pieces in less than 30 seconds. The noise is deafening, 120 decibels that can be heard kilometers away. Magnetic separation uses 2-ton electromagnets to extract iron and steel from mixed fragments. Eddy currents separate aluminum and copper through induced magnetic fields. Density separation uses heavy fluids to isolate non-ferrous metals from plastics and glass. Final purification removes microscopic contaminants through flotation and electrostatic separation. The result is 99.5% pure steel pellets, ready to feed steel furnaces and be reborn as new metal. At the heart of modern megafactories are next-generation shredders that operate like intelligent mechanical monsters. These 3,000-ton giants use dynamically balanced hammers and AI-controlled feeding systems to optimize fragmentation, reducing energy consumption by 30% compared to previous generations. Hyperspectral computer vision systems analyze fragments in real time, identifying more than 50 different types of materials through unique spectral signatures. Deep learning algorithms process 100,000 images per second, directing compressed air jets that separate materials with 99.8% precision. Superconducting magnetic separators use magnetic fields 10 times more intense than conventional magnets, operating at cryogenic temperatures of -196 degrees Celsius. This technology enables separating metals with similar magnetic properties, recovering special alloys that were previously lost as contamination. Collaborative robotics works alongside humans in complex dismantling tasks. Robotic arms equipped with force sensors and three-dimensional vision remove delicate components without damaging valuable materials. Augmented reality systems guide human operators through optimized procedures. Predictive artificial intelligence analyzes vehicle arrival patterns, optimizing production flow and preventive maintenance. Optimization algorithms calculate ideal processing sequences, maximizing valuable material recovery and minimizing downtime. Industrial blockchain tracks each component from arrival to final product, ensuring complete chain of custody and origin certification for recycled materials. Buyers can verify that purchased steel actually comes from sustainable sources. The obsession with purity in automotive recycling rivals pharmaceutical industries. Each batch of recycled steel must meet more than 150 different chemical and physical specifications, with tolerances that don't allow variation exceeding 0.01% in critical elements like carbon, sulfur, and phosphorus. Optical emission spectrometry analyzes chemical composition of samples in real time, detecting impurities at parts per million concentrations. Automated laboratories process 500 samples daily, ensuring each ton of recycled steel meets the most rigorous steel industry standards. Mechanical resistance tests subject recycled steel samples to extreme forces, verifying that properties are identical or superior to virgin steel. Universal tensile machines apply loads up to 100 tons, measuring elasticity, breaking strength, and fatigue with 0.1% precision. Ultrasonic inspection detects microscopic non-metallic inclusions that could compromise final steel quality. Automated systems scan 100% of production, rejecting any material with defects exceeding 0.5% of cross-sectional area. Gas analysis measures hydrogen, oxygen, and nitrogen dissolved in steel, elements that can cause brittleness and premature failures. Mass spectrometers detect gas concentrations at parts per billion levels, ensuring steel with exceptional purity. International certification requires complete documentation of origin, processing, and quality. ISO 14001 and IATF 16949 standards establish global standards, ensuring recycled steel meets the most demanding automotive industry specifications. Automotive recycling represents one of the greatest environmental victories of modern industry. Each ton of recycled steel saves 1.4 tons of iron ore, 740 kilograms of coal, and 120 kilograms of limestone, reducing carbon dioxide emissions by 58% compared to virgin steel production. Carbon capture systems in megafactories capture 95% of carbon dioxide emissions generated during processing, converting them into useful carbonates for construction industry. This technology transforms a polluting byproduct into valuable raw material, creating perfect circular economy. Automotive fluid purification recovers 98% of oils and liquids drained from vehicles. Fractional distillation and molecular filtration restore original properties, enabling reuse in new vehicles. Each liter of recycled oil prevents contamination of 1 million liters of water. Automotive plastic recycling uses controlled pyrolysis to decompose complex polymers into basic monomers, which are repolymerized into new plastics. This technology enables infinitely recycling materials that were previously considered non-recyclable. Renewable energy powers 70% of operations through solar panels installed over storage yards and wind turbines that harness air currents created by industrial operations themselves. Battery storage systems ensure continuous operation even during periods without wind or sun. Soil remediation uses hyper-accumulator plants that absorb heavy metals from areas contaminated by decades of operation. Genetically selected sunflowers and willows can extract 90% of contaminants, restoring ecosystems in years instead of decades. The industry's biggest challenge has a name: material cross-contamination. A single piece of stainless steel mixed with carbon steel can contaminate 100 tons of final product. X-ray detection systems and laser spectrometry identify contaminants instantly, directing supersonic air jets that remove them with millimetric precision. Electric vehicles created unique challenges with lithium batteries that can explode if processed incorrectly. Specialized robots operate in inert atmospheres to safely remove batteries, while cryogenic systems freeze cells to prevent uncontrolled thermal reactions. Modern composite materials like carbon fiber resisted traditional recycling. Controlled atmosphere pyrolysis at 600 degrees Celsius decomposes resins, recovering intact fibers that maintain 95% of their original properties. These recycled fibers cost 50% less than virgin fibers. Commodity price fluctuations made operations economically unstable. Automated futures contracts and product diversification stabilize revenues. AI algorithms adjust operations in real time based on market prices, maximizing profitability regardless of volatility. Stringent environmental regulations required massive investments in pollution control. Continuous monitoring systems detect any environmental deviation instantly, triggering automatic corrections before limits are exceeded. Perfect compliance became standard operation. Giant material logistics created operational bottlenecks. Automated transport systems move 500 tons of material per hour through intelligent conveyors and robotic cranes. AI optimization calculates ideal routes, eliminating congestion and maximizing throughput. Recycled steel from automobiles transcends its origin, becoming the backbone of modern industry. New vehicles incorporate 25% recycled steel in their structure, creating circular economy where cars literally are reborn from their own ashes. Each new sedan contains metal from approximately 4 previous vehicles. Civil construction consumes 40% of all recycled automotive steel. Structural beams of skyscrapers, concrete reinforcement, and bridge structures use steel that was once bumpers and chassis. The Empire State Building could be built with recycled steel from just 50,000 cars. Naval industry uses recycled steel plates to build cargo ships and oil platforms. The exceptional purity of recycled steel makes it ideal for marine applications, where corrosion resistance is critical. Each container ship contains steel equivalent to 2,000 recycled automobiles. Appliances incorporate recycled steel in refrigerators, washing machines, and ovens. The white goods industry values recycled steel for its chemical consistency and superior magnetic properties. Each modern refrigerator contains steel from approximately half an automobile. Railway infrastructure uses recycled steel for rails, metal sleepers, and station structures. The exceptional durability of recycled steel makes it ideal for high-tension applications. A 100-kilometer railway line consumes steel equivalent to 10,000 recycled cars. Energy industry uses recycled steel in wind towers, solar structures, and oil pipelines. The purity and resistance of the material make it perfect for applications requiring decades of operation without maintenance. Each wind turbine contains steel from approximately 150 automobiles. The future of automotive recycling is being rewritten by technologies that seemed like science fiction a decade ago. Quantum artificial intelligence will optimize material separation at molecular level, identifying and isolating individual elements with atomic precision. Perfect recycling of 100% of materials will become reality. Molecular robotics will enable automatic vehicle dismantling at atomic level. Specialized nanobots will dissolve specific chemical bonds, separating materials without loss or contamination. Each atom will be recovered and reused, eliminating the concept of waste. Additive manufacturing will revolutionize use of recycled materials. Three-dimensional metal printing will create parts directly from recycled steel, eliminating need for traditional casting and rolling. Automotive components will be printed on demand using material from previous vehicles. Autonomous vehicles will transform recycling patterns. Shared cars will last 10 times longer than private vehicles, reducing recycling volume but increasing technological complexity. Self-diagnostic systems will alert when components need to be recycled. Space recycling will process vehicles in orbital stations, using zero gravity to create alloys impossible on Earth. Microgravity will enable perfect material separation by density, creating ultra-pure metals for aerospace applications. Biorecycling will use genetically modified microorganisms to extract metals from complex components. Specialized bacteria will selectively dissolve specific materials, enabling recovery of rare elements from automotive electronic circuits. Digital circular economy will track each atom through molecular blockchain, ensuring origin and purity of recycled materials. Digital twins of vehicles will enable optimizing recycling before cars even reach end of life. The journey of billions of tons of metal from old cars being transformed into new steel reveals one of the greatest achievements of modern circular economy. From abandoned vehicles being shredded to pure steel emerging from purification processes, we witness industrial resurrection where death transforms into new life. 80 million vehicles recycled annually represent more than numbers. They're testimony to an industry that transformed waste into resources more valuable than virgin ores. Each ton of recycled steel incorporates decades of separation innovation, centuries of metallurgical knowledge, and technologies operating at the limits of materials physics. The revolutionary technology behind this process, from 3,000-ton shredders to hyperspectral vision systems, from superconducting separators to quantum artificial intelligence, demonstrates how environmental necessity drives innovation. Processes that automatically separate 200 types of materials, systems that detect molecular contamination, machines that operate with atomic precision. Absolute quality emerges from this technological complexity. Recycled steel that exceeds virgin material specifications isn't an engineering accident, but a product of meticulous science. Each test, each analysis, each control parameter ensures recycled materials are superior to originals. The civilizational impact transcends the Megafactory. Automotive recycling saves natural resources, equivalent to entire continents, reduces carbon emissions on planetary scale, and creates economy where end becomes beginning infinitely. Sustainable civilization exists because we learn to transform death into rebirth. This is the story of how humanity mastered the art of industrial resurrection, transforming automotive graveyards into nurseries of new materials. Automotive recycling is not just an industrial process, it's the materialization of perfect circular economy, where each end is a new beginning, each waste is a resource waiting, testimony that we can create infinite abundance from finite resources. Now that you've discovered the secrets behind transforming billions of tons of old cars into new steel, one question remains. How will you see abandoned vehicles with new eyes? The next time you pass a junkyard or see a car being towed, remember you're witnessing not an end, but a beginning. That seemingly worthless vehicle contains materials that will be reborn as new cars, buildings, and infrastructure that will sustain future generations. Share this revelation with friends and family. Show them that automotive recycling isn't just scrap collection, but one of the most sophisticated industries on the planet. Let them discover that each new car contains the reborn soul of previous vehicles, creating industrial immortality. Tell us your experience. What was the most surprising moment of this journey? Did you imagine automotive recycling involved 3,000-ton shredders, artificial intelligence, and space technology? What other circular economy processes would you like to see unveiled? Challenge your perception about waste and resources. How many other wastes around you are, in fact, raw materials waiting for rebirth? Old electronics, used clothes, discarded packaging. Each one may hide extraordinary transformation potential. Value the engineering behind sustainability. Engineers, chemists, and scientists dedicated entire careers so finite resources could become infinitely reusable. Each ton of recycled steel is a tribute to human genius applied to planetary preservation. The circular economy revolution continues, transforming each waste into opportunity, each end into new beginning. You are now part of this discovery. Spread the knowledge and help others see the extraordinary rebirth potential that surrounds us daily. Special thanks to the leading companies in the automotive recycling industry that opened their doors, metaphorically, to reveal the secrets behind this extraordinary technology. To the teams of environmental engineers, materials specialists, and scientists who dedicate their lives to transforming waste into valuable resources. Deep gratitude to circular economy pioneers, visionaries who imagined a world where nothing is wasted, and innovators who transformed recycling from necessity into precision science. Your contributions made it possible to create infinite abundance from finite resources. Special recognition to separation technology developers, automated systems engineers, and purification specialists who elevated automotive recycling to the level of scientific art. Each innovation represents years of research dedicated to the pursuit of perfect sustainability. Tribute to workers who operate in challenging environments, handle hazardous materials, and ensure each process meets the most rigorous quality and environmental safety standards. Although systems are automated, brilliant human minds designed each process and continue innovating to achieve impossible sustainability. And, primarily, gratitude to you for dedicating your time to understanding the complexity and beauty behind processes that normally remain invisible. Your curiosity fuels our passion for unveiling the secrets of the factory-made world. Research and narrative. Factory-made, team technical consulting, industrial recycling and circular economy. Specialists. Scientific review, materials analysis, and environmental sustainability laboratories. Continue exploring with us the mysteries of modern circular economy. The world is full of extraordinary processes that transform waste into valuable resources waiting to be discovered. The next time you see an old car, remember, you're contemplating one of the greatest achievements of industrial rebirth engineering.